Pluto is a faraway and unpretentious, truly certifiable planet that was once a piece of our planetary framework. At any rate, progressing, upsetting explanations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They recommended that this far-off world is on a potential crash course with Neptune. Be that as it may, how could this really happen? What may be the results of such a huge event? Are we seeing a puzzling, giant catastrophe? Or is there more to this approaching, enormous accident? Join us as we look at the scientific possibilities of a Pluto-Neptune impact. Pluto, a previous planet that was renamed as a dwarf planet, remains a subject of interest in the immense universe. As indicated by later hypotheses by leading specialists, Pluto's orbit is hazardously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are raising alarms about a possible catastrophic collision between these two planets, which could have major implications for Earth. But how is such an event even conceivable? Pluto's journey around the Sun is unlike that of any other planet in our nearby solar system. It requires a stunning 248 years to complete a single orbit. Since its discovery in 1930, it has not yet completed one full revolution. However, the interest doesn't stop there. Pluto's orbit is marked by its exceptionally unconventional shape, straying entirely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more interesting is its inclination, which is 17 degrees to the ecliptic plane. The way Pluto follows its path is undeniably more whimsical compared to other planets. This inclination and capriciousness add layers of complexity to its orbital design. Perhaps one of the most fascinating aspects of Pluto's orbit is its relationship with Neptune's. For around 20 years during each orbit, Pluto actually draws closer to the Sun than Neptune, opposing what we might expect from their positions in the solar system. This prompts the obvious question: why hasn't Pluto crashed into Neptune? The answer lies in the gravitational effects of other planets. The study of Pluto's orbit began soon after its discovery. Initially, astronomers tried to grasp its unusual path. Unlike other planets whose orbits lie mostly near the ecliptic plane, Pluto's orbit sticks out because of its steep inclination and irregular shape. The movement evolved with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit, despite these complexities, is evidence of the intricacies of celestial mechanics. The three-body problem in space involves determining how three objects, like Pluto, Neptune, and the Sun, move and affect one another with their gravity. It's like trying to predict their movements based on their initial positions and the gravitational pulls they apply on each other. In Pluto's case, this problem reveals how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complicated way. Key terms like non-simultaneous libration, orbital precession, and VSK wobbling are essential for this puzzle, as explained by astrophysicists. Non-simultaneous libration, with respect to Pluto and Neptune, means that when Pluto crosses Neptune's orbit, it is positioned about 90 degrees away from Neptune. This spatial separation is crucial in keeping their orbits from meeting. Orbital precession, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes nearest to Neptune or any other giant planet, it is positioned far above their orbital plane, adding another layer of protection from potential collisions. Another key factor in this situation is VSK wobbling, named after three researchers, V, Z, and K, who studied the movement of celestial objects. This wobbling describes how Pluto, Neptune, and the Sun pull on each other with their gravity. This gravitational interaction influences Pluto's erratic movement close to the Sun. Despite Pluto's orbit appearing tumultuous, this wobbling maintains its motion over long periods. The VSK wobbling shows that even in the seemingly chaotic universe, patterns and rules achieve some level of order. These forces ensure that Pluto's orbit remains stable, preventing it from colliding with Neptune or drifting off course. This three-body problem is vital to understanding how these orbits evolve under gravitational interactions. Studying this helps us learn more about Pluto, our solar system, and even distant galaxies and their stars. Mathematical simulations in the late 1980s revealed that, despite its settling properties, Pluto's orbit is actually quite erratic. Small changes in initial conditions could lead to enormous differences over centuries. However, these idiosyncrasies of Pluto's orbit have been shown to maintain stability over incredibly long timescales. Later computer simulations provided insights into how giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a unique relationship with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps keep Pluto's orbit stable. But Neptune isn't working alone. Jupiter's massive gravity also plays a crucial role in stabilizing Pluto's orbit. Saturn too contributes. These findings suggest that Jupiter's gravitational force is strong enough to ensure Pluto stays on a steady course for eons, possibly indefinitely. It appears that Neptune, Jupiter, and Saturn work together to ensure Pluto continues its safe journey through space without running into trouble. These characteristics are crucial for maintaining stability in the solar system. Without these stabilizing forces, our solar system could be much more chaotic. Bodies like Pluto could collide with others or, alternatively, be ejected from their orbits, triggering a chain reaction with other celestial bodies. For Pluto, especially with discussions about its potential impact with Neptune in the future, understanding its orbit is essential. This gives a clearer picture of the dynamic nature of the solar system. The case of Pluto shows that even the most seemingly unstable orbits can achieve a state of agreement through the complex interactions of gravitational forces. The delicate balance between gravitational forces ensures the stability of Pluto's orbit and its unique relationship with Neptune. While the possibility of a crash between the two may sound disturbing, the mechanisms of orbital elements make such an event extremely unlikely in the near future. The resonance between Pluto and Neptune ensures their orbits never converge at the same time. This unique relationship is a result of millennia of gravitational interactions that have shaped the paths of celestial bodies in the solar system. It's a testament to the intricate dance of planetary mechanics, where chaos results in order over immense timescales. Additionally, advanced simulations and mathematical modeling continue to refine our understanding of these interactions. Astrophysicists use supercomputers to simulate the movements of Pluto, Neptune, and other bodies in the solar system over billions of years. These studies reveal not only the stability of Pluto's orbit, but also the resilience of the solar system as a whole. Despite its renaming as a dwarf planet, Pluto remains a source of interest for both scientists and the general public. Its cold surface, strange atmosphere, and peculiar orbit offer clues about the formation and evolution of the solar system. The intricate interactions between celestial bodies in our solar system demonstrate that even seemingly chaotic systems can maintain a delicate equilibrium over long periods. As we continue to study Pluto and its relationship with Neptune, we gain a deeper understanding of the underlying principles that govern not only our solar system, but the entire universe. Despite its demotion from a planet to a dwarf planet, Pluto remains a compelling object of study. Its icy surface, bizarre atmosphere, and eccentric orbit offer clues to the processes that shaped our solar system and continue to influence its evolution. Pluto's story also emphasizes the interconnectedness of all celestial bodies, highlighting the importance of each planet, moon, and distant object in the cosmic ballet. The ongoing research into Pluto's orbit, particularly its interaction with Neptune, is an excellent example of how science constantly evolves. What was once thought to be a simple and predictable system is now understood to be far more complex and dynamic. The gravitational interactions between Pluto, Neptune, and other planets like Jupiter and Saturn continue to fascinate astronomers and astrophysicists. As our technology and models improve, we can refine our predictions and deepen our understanding of Pluto's place in the vastness of space. Advanced simulations, especially those involving large-scale supercomputers, will continue to provide new insights into the behaviors of objects in our solar system. These models help us predict potential future changes in Pluto's orbit and the broader dynamics of the solar system. In the broader context of space exploration, Studying Pluto also provides an opportunity to explore how small bodies in the solar system behave and interact with larger planets. While Pluto may be distant and cold, it holds valuable information about the early solar system, potentially offering insights into the formation of planets, the development of life, and even the future of planetary science. In conclusion, Pluto's status as a dwarf planet does not diminish its importance or its capacity to inspire scientific curiosity. Its unusual orbit and fascinating relationship with Neptune continue to provoke important questions about the forces that shape the universe. Whether or not Pluto and Neptune will ever collide is still uncertain, but the mechanisms that prevent such a disaster, resonance, gravitational interactions, and orbital stability, are a testament to the complexity and harmony of the cosmos. By understanding Pluto's orbit and its interactions with Neptune, scientists are also learning more about the broader behavior of planets and other celestial bodies. These findings not only improve our knowledge of the solar system, but also contribute to our understanding of planetary formation, stability, and evolution. As we continue to unlock the mysteries of Pluto, we are reminded of the intricate beauty of the universe and our place within it, that can emerge from the exchange of gravitational powers as we investigate the secrets of space. Pluto will, without a doubt, keep on moving, marvel, and interest for a long time into the future. Likewise, orbital mechanics also highlight the meaning of steady discernment and assessment of these eccentricities to more promptly understand our place in the universe. Investigating the significance of space frequently drives us to stand up to the exceptional nature of divine bodies. For example, Pluto's orbit is an ideal illustration of this peculiarity. The idea of orbital turmoil, which alludes to the fragile reliance of a heavenly body's orbit on its starting circumstances, is obviously shown for Pluto. This really means that indeed, even slight changes in the dwarf planet's position or speed can altogether change its long-term orbit. Utilizing mechanized simulations has been incredibly helpful for specialists in translating how Pluto moves in space. These simulations use complex mathematics to demonstrate how Pluto and other space objects, like Neptune, interact gravitationally. By tweaking small details in the simulations, space researchers can see how even minute changes can result in critical differences in Pluto's possible position. In the late 1980s, these simulations uncovered something interesting about Pluto's orbit. Regardless of having stabilizing features like asymmetric libration and orbital precession, Pluto's orbit can still be inconsistent and eccentric. Even a slight variation in Pluto's position or speed at the start can lead to an entirely different orbit within just a few years. Yet, despite this chaos, Pluto's orbit remains stable over immense timescales, crossing billions of years. This shows that Pluto's excursion around the Sun has a certain order, even though it might seem turbulent at first. Predicting heavenly developments, especially when they involve sporadic orbits like Pluto's, is a gigantic challenge. The inherent instability of such systems means that long-term forecasts are often filled with uncertainties. While numerical models provide astounding tools for understanding and predicting the movements of heavenly bodies, they too highlight the limitations of our predictive capacities. These models depend heavily on the accuracy of initial conditions, and even small errors or deviations can lead to vastly different results, making exact forecasts an arduous task. Beyond the turbulent nature of planetary orbits, Pluto helps remind us of the ever-changing and dynamic nature of the universe. While we have made significant progress in understanding space, Pluto's case serves as a reminder of how limited our knowledge of the universe remains. Grasping the gravitational effects of the giant planets on Pluto's orbit offers significant insights into the broader dynamics of the solar system. It illustrates how the presence and position of each planet can profoundly influence the stability and direction of other bodies within the system. So why are leading astrophysicists recently raising concerns about a potential collision between Pluto and Neptune? Despite the complex forces attempting to prevent such an event, Neil deGrasse Tyson, a prominent astrophysicist and a key figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, especially the captivating case of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, provides keen analysis on the evolving nature of celestial mechanics and the public's interest in the lesser-explored corners of space. Tyson's position on Pluto's renaming is rooted in the ever-evolving understanding of our solar system. He views the renaming not as a diminishment, but as a significant adjustment to our growing understanding of the various bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of constant learning and adaptation. He sees the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The fascination with these questions keeps the exploration of space so intriguing. Anyway, despite Tyson's optimism, his thoughts on Pluto's potential impact with Neptune paint a different picture. His concerns about the instability of Pluto's orbit suggest that we may still have many mysteries to uncover. Will Pluto crash into Neptune? Or is this just another moment of chaos in the ever-changing universe of space? Only time and further investigation will tell. For now, we are left with a deeper curiosity about how little we still truly understand about our own solar system. We continue to study these divine peculiarities, determined to uncover more of the mysteries that lie beyond. The possibility of a Pluto-Neptune crash raises unexpected questions about the unpredictable and captivating universe in which we exist. The potential for a collision between Pluto and Neptune challenges our traditional understanding of planetary stability. The fact that two celestial bodies with such vastly different characteristics could impact is both disturbing and intriguing, especially given the current relative stability of their orbits. Pluto, located in the outer reaches of the solar system, far from the major planets, is a frozen world covered in nitrogen ice, with an atmosphere made primarily of nitrogen, methane, and carbon monoxide. On the other hand, Neptune, a gas giant, consists mainly of hydrogen, helium, and lighter elements, with a thick, deep atmosphere. A collision between such disparate bodies would drastically alter their compositions and behaviors, possibly creating an event visible across vast astronomical distances. What makes this hypothetical impact especially fascinating is the influence of other planets and bodies in the solar system. While Neptune's gravity plays a dominant role in maintaining Pluto's orbital stability, it is not the only factor at play. Jupiter, the largest planet in the solar system, also has a stabilizing effect on Pluto's orbit, preventing it from wandering too far into Neptune's domain. Additionally, Saturn's gravitational influence further complicates the dynamics of the outer solar system, making a catastrophic event between Pluto and Neptune unlikely. However, ongoing research has shown that the relationship between Pluto and Neptune is not as straightforward as a direct impact course. The gravitational resonance between the two planets, where Pluto completes 2 orbits around the Sun for every 3 of Neptune's, creates a sort of cosmic lock that prevents them from coming into direct contact. This resonance is a key reason why Pluto and Neptune's orbits, despite crossing in the vast expanse of space, have never resulted in a collision. Despite the gravitational resonance preventing a direct collision, the complex dynamics of the Pluto-Neptune system continue to fascinate astronomers. The intricate balance between the two bodies, along with the contributions of other planetary forces, maintains their relative positions within the solar system, ensuring that Pluto and Neptune avoid direct interaction despite their orbits crossing. However, this stability does not mean that the future of these bodies is set in stone. The long-term behavior of the solar system, particularly in the outer regions, remains a subject of significant study and speculation. Changes in the positions or velocities of other planets, or even the influence of distant stars or passing celestial objects, could alter the gravitational forces at play, potentially causing shifts in Pluto's orbit over millions of years. The precise impact of such changes is still not fully understood, and researchers continue to use sophisticated models and simulations to predict and study these potential scenarios. One interesting aspect of the Pluto-Neptune system is the way in which their gravitational resonance operates to prevent direct collisions. This resonance, in which Pluto completes 2 orbits for every 3 of Neptune's, ensures that the two bodies are never at the same point in their orbits at the same time. As a result, even though their paths cross in space, they are never in direct collision courses. The resonance creates a safe, stable rhythm that helps maintain the relative stability of both planets' orbits. Nonetheless, while the resonance provides a layer of stability, it doesn't completely eliminate the possibility of future orbital shifts. Over extremely long periods, small changes can accumulate, leading to alterations in the gravitational interactions between Pluto, Neptune, and other bodies in the solar system. The delicate balance of forces that currently exists could be disrupted by unforeseen cosmic events, such as the influence of a passing star or the gradual migration of the planets. The study of Pluto and Neptune's orbits and the broader dynamics of the outer solar system serves as a reminder of the complexities and intricacies of celestial mechanics. It highlights how seemingly simple systems can hold deep mysteries, and how even the smallest forces can have significant long-term effects on the trajectories of planets and other objects in space. As technology continues to improve and our understanding of the cosmos deepens, we may discover new insights into how the orbits of distant objects like Pluto evolve over time. The study of these distant bodies is not just about understanding Pluto itself, but about gaining a broader understanding of how our entire solar system functions and how it may continue to evolve in the future. In the meantime, as Pluto continues its journey through the outer reaches of the solar system, its story remains one of both mystery and discovery. While the potential for a collision with Neptune may seem unlikely, the ongoing study of their orbits and the forces that shape them continues to captivate scientists and enthusiasts alike, offering a glimpse into the dynamic and ever-changing nature of our universe. Through continued research and exploration, the mysteries of Pluto and its place in the solar system will undoubtedly unfold, providing more answers and sparking even greater questions about the vast, cosmic landscape we are only beginning to understand.